This is the review of exponents for pre-calculus. Okay, for questions 1 through 6, we're simplifying the expression. So on number 1, notice that we're multiplying everything inside the parentheses. So what you're going to want to do is raise every single power to the 5th. So we'll have negative 2 to the 5th, x cubed to the 5th, and y squared to the 5th. Now if you'll remember your rule, a power raised to the power, you multiply the exponents. Okay, so we have negative 2 to the 5th. Well, negative 2 times itself 5 times is negative 32. X cubed to the 5th is x to the 15th. And y squared to the 5th is y to the 10th. On number 2, we need to do the same thing that we did in number 1 to the top of the expression. So we have 2 cubed over x cubed, and again that's because we're multiplying inside the parentheses, over negative 8x cubed. Well, 2 cubed is 8, and 8x cubed divided by negative 8x cubed is just negative 1. Okay, on number 3, we need to distribute the factor in front to both of the terms inside the parentheses. So when you distribute, you add the exponents. This is the rule, a to the x times a to the y is a to the x plus y. If you see the base twice here, we're multiplying. We want to add the exponents. So you have a times a is a squared. B to the negative 2 plus 2 makes 0. 1 times 3 is 3. A times 1 is a. B to the negative 2 times b cubed, we add the exponents. So negative 2 plus 3 is just 1. So the only thing I can do here is change b to the 0 to 1. So a squared times 1 is just a squared. Bring down minus 3ab. Okay, on number 4, again, I'm multiplying inside the parentheses, so I want to raise each power to the exponent negative 1. So I multiply. So I have a to the negative 1, x to the negative 2, divided by a to the negative 2, x to the negative 2. Well, the x to the negative 2's cancel out, and I'm left with a to the negative 1 minus negative 2. This is your rule, a to the x over a to the y is equal to a to the x minus y. You subtract the exponents if you're dividing and you have the same base. So negative 1 plus 2 is positive 1, and that's my answer, a to the 1. Okay, now number 5, we have negative 5 over 2 to the negative 3 times 5 to the 0. Well, 5 to the 0 is just 1, so anything times 1 is itself, so I can really ignore this factor here. The negative exponent flips a fraction, so I would do that first, and you make the exponent positive at that point. Then attach that 3 to the top and the bottom. Okay, so 2 cubed is 8. Negative 5 cubed is negative 125. Okay, number 6 will work exactly like we did number 3. You distribute the lead factor. So 2 times 1 is 2. Into the 1/3 times into the 2/3 is into the 1/3 plus 2/3. You add the exponents. 2 times 1 is 2. Into the 1/3 times into the negative 1/3, you add the exponents. Okay, so 2n to the 3/3 is just 2 into the 1. Here, 1/3 minus a third is 0, so 2n to the 0 is 2 times 1. So that's 2n plus 2 for the answer. Okay, on number 7, simplify to a single term leaving no radicals or negative exponents. So on the top, we're multiplying inside the parentheses, so I want to multiply each exponent by negative 1. On the bottom, I can't do anything yet. So I have x to the negative 1, y to the negative 3, divided by x to the negative 3, y to the negative 3. Well, these cancel out. Now I have x to the negative 1 over x to the negative 3. Because I have the same base, I subtract the exponents. So negative 1 plus 3 is equal to 2, and that's my final answer. On number 8, I noticed that each of these have a common base of 3. This negative is not a part of the base. It's outside parentheses, it's not being cubed, so it's just out front. Okay, so we'd have 3 cubed. 81 is 3 to the 4. Divided by 3 squared is 9 squared. Okay, now I want to multiply these exponents. So I have negative 3 cubed, 3 to the negative 4 divided by 3 to the 4. On top, I have the same base and I'm multiplying, so I want to add the exponents. Remember, you just write the base one time at this point. You don't multiply the bases. Okay, so 3 plus a negative 4 is negative 1. Now I have the same base. I want to subtract the exponents. And that leaves me with negative 3 to the negative 5. A negative exponent pulls the 3 to the 5th to the denominator. And that equals negative 1 over 243. Okay, on number 9, the first thing I want to do is take care of this negative exponent. So I'm going to flip this fraction. And make the exponent positive. Now I want to multiply this exponent by every exponent inside the parentheses. So I'll have 6 squared, x to the negative 10, y to the 6th, divided by 3 squared, x to the 10, y to the negative 6. Okay, at this point, I want to go ahead and take care of my coefficients. So I have 36 over 9, which is 4. The x's have the same base. I'm going to subtract the exponents. So negative 10 minus 10 is negative 20. And then the y's, I have the same base. I want to subtract the exponents. So 6 minus negative 6 is a positive 12. The only thing I can do from here is move x to the 20th to the denominator. So I have 4y to the 12th divided by x to the 20th. Okay. On number 10, I want to start by taking this square root and rewriting it as an exponent of 1/2. Okay, so I have c cubed d to the negative 1/3 divided by c to the 1/3 d cubed, all raised to the 1/2. Again, a square root is an exponent of 1/2. A cube root would be 1/3, fourth root 1/4, etc. Okay, so now what I'm going to do is multiply 1/2 by every single exponent. So I have c to the 3/2, d to the negative 1/6, divided by c to the 1/6, d to the 3/2. Okay, 3 times 1/2 is 3/2, negative 1/3 times 1/6 is negative 1/6, etc. Okay, now I have the same base here, c, so I want to subtract the exponents. Same thing here, I have d's, so I want to subtract the exponents. Now to do that, you have to have a common denominator. So I'm going to change this to c to the 9/6. If I take 2 and I multiply by 3, I get 6. So I have to do that to the top as well. 3 times 3 is 9. Divided by c to the 1/6, d to the negative 1/6, d to the 9/6. Okay, so 9/6 minus 1/6 is 8/6. Negative 1/6 minus 9/6 is negative 10/6. Okay, and I can rewrite this as, I'm running out of room here, c to the 4/3 all over d to the 5/3. Okay, that's c raised to the 4/3 divided by d raised to the 5/3. Okay. All right, one last problem for simplifying. Remember order of operations. You want to do what's in the parentheses first. So here I'd have 64 plus 36 raised to the 1/2. That's 100 raised to the 1/2. An exponent of 1/2 means to take the square root. So our answer is 10. Okay, now we're going to solve some exponential equations. So remember that the first step that you want to do if x is an exponent is rewrite both sides with the same base. So that's what we're going to do on 12 all the way through 16. You want to rewrite both sides with the same base. So the common base here is going to be 3. So 9 is 3 squared. 81 is 3 to the 4th. Okay, so here I have a power to a power, so I multiply. and set the exponents equal to each other. So once you have both sides with the same base, you can drop the base and set the exponents equal to each other. Now divide by 8, x is 1/2. Okay, same thing here. 27 is 3 cubed. 9 is 3 squared. Okay, so I multiply here and I have 3x for my exponent. Here I'd have 7 plus 18. Okay, remember you have the same base, so you want to add the exponents. Well, here we multiplied 2 times 9 to get 18, so I have 7 plus 18. So that's 3x equals 25. Divide by 3. Okay. On number 14, we have base 2. So 4 is 2 squared. So I have 6 minus x is equal to 2 times 2 is 4. 2 times x is 2x. You multiply because you have a power to a power. So now I'm going to add x to both sides, and I'm going to subtract 4 from both sides. So 6 minus 4 is 2. 2x plus x is 3x. Divide by 3. Okay, so x is 2 over 3. On number 15, keep the 3. Rewrite the square root of 27 as 3 cubed divided by 2. Okay, the square root gives me a denominator of 2, and I'm raising 3 to a power of 3. So the bottom is the root, the top is the power, and you just bring down this other 3. 9 is 3 squared, and you raise it to the 2x. Okay, so 3 to the 1 times 3 to the 3 halves. Again, that's the square root of 3 cubed, which is the square root of 27. So I have the same base. I want to add the exponents. So I have 3 to the 1, which I'm going to write as 2 over 2, plus 3 over 2. Remember, to add these, you have to have a common denominator. Here, a power to a power, you multiply. So we have 3 to the 4x. When I set my exponents equal to each other, I'm going to have 5 halves is equal to 4x. Okay? Now I'm going to go ahead and I'm going to get rid of the fraction because I think that's the way most of my students like to work these. So you have 5 is equal to 8x, divide by 8, x is equal to 5/8. Okay. On number 16, we have a common base of 3, so I'm going to rewrite 9 as 3 squared. And I'm going to rewrite 3 to the x as 3 to the x squared. Okay, so here this is 4x. I'm going to add it to 5 because I have the same base and I'm multiplying, so you add the exponents. It's equal to x squared. I'm going to solve this as a trinomial. So let's move the 4x and the 5 to the other side. So that I have 0 is equal to x squared minus 4x minus 5. And I'm going to factor it. Okay. So negative 5 and positive 1 are going to add to negative 4 and multiply to negative 5. So I have x minus 5, x plus 1, and x is equal to 5 and negative 1. Okay, you set each factor equal to 0 and solve for x. Okay, now if you're in pre-AP, you need to continue watching. If you're in regular, you're done, and study and be ready for that test tomorrow. Okay, on 17, we're going to factor, so we need to identify the GCF. Okay, the GCF, y to the negative 3 is going to be our common factor. Okay, I don't have an x in this term, so I can't use x as a factor, and you always choose the y with the smallest exponent. So I need to divide each term by y to the negative 3 to see what goes inside the parentheses. Okay? Well, y to the negative 3 divided by y to the negative 3 is 1. Minus, here I'd keep my x squared. Y to the negative 1 divided by y to the negative 3. I subtract the exponents. So negative 1 minus negative 3 is going to be 2. Okay. You could leave it like this, or you could continue factoring because we have a difference of perfect squares here. So you could rewrite it as 1 plus xy. 1 minus xy. On this one, the GCF is x squared plus 1 to the negative 3 halves. Negative 3 halves is smaller than negative 1 half, so that's the GCF. So we put that first. And then to get what's in parentheses, we divide by the GCF. Okay, so here it cancels out, so we'd have 1. We'd have minus 3, and then I'd have x squared plus 1 to the negative 1/2 minus negative 3/2. Well, negative 1/2 minus negative 3/2 is equal to 2/2, which is an exponent of 1. Okay, now it's just a matter of simplifying. So I'd have x squared plus 1 to the negative 3/2, just bring that down. 1 minus 3x squared minus 3. You distribute this 3. Okay, continue. X squared plus 1 to the negative 3/2. 1 minus 3 is negative 2. So I have negative 3x squared minus 2. And that's your final answer on that one. Okay, moving on to the graphs. Number 19. It says graph 7 to the x below and state the equations for the asymptote. Okay, the asymptote is still going to be y equals 0. There's no transformation from the parent function. The only thing is that I have a different base than what we looked at in the notes. Okay, so the anchor point is going to be exactly the same. If you think about it as a table, when x is 0, y is 7 to the 0, and 7 to the 0 is 1. So we have 0, 1. If I had, say, negative 1, I'd have 7 to the negative 1, which is 1/7. So something really close to the axis. 1, I'd have 7 to the 1, which is 7. So it'd be way up high. And then it would continue upward like that. Okay. On number 20, we're going to graph the transformation. So the transformation here is right 1. Okay, the minus 1 attached to the x means to move it to the right 1. So I'm going to take that anchor point, 0, 1, and I'm going to move it right 1. And then I'm going to go over 1 and up 6. Just like I did here, over 1 up 6. And those are the points I'm going to use. Okay, the asymptote did not change. It only changes if you move the function up and down. Okay, let's look at the back. Okay, on number 21, we're moving down 2 units because the negative 2 is outside the parent function. So in this case, our horizontal asymptote went from 0 down 2 to negative 2. Okay, so our asymptote is now here. So we start with the anchor point. We move it from 0, 1 down 2 to 0, negative 1. Then go over 1, up 6, just like we did with the parent function. Okay. On this one, we're going left 2 because the plus 2 moves it to the left, and up 1. So start with the asymptote. It went from 0 up 1 to y equals 1. Go to your anchor point and move it up 1 and move it left 2. Then go over 1, up 6, and that's your graph. Okay. On 23, it says write an equation in the form of y is equal to b to the x minus h plus k for the function shown if it passes through the point 1, negative 8. So that's our x and y. Okay, always start with your anchor point from your parent function and identify the transformation. So we moved down 1, 2, 3, 4, 5. And that tells us the value of k. So that's going to be minus 5 for k. Okay, so I have y is equal to b to the x. I don't have an h because it didn't move left or right. So minus, I guess you could put 0, minus 5. Now plug in x and y. So we have negative 8 is equal to b to the 1, excuse me, minus 5. Add 5 to both sides. Negative 8 plus 5 is negative 3 is equal to b. So now rewrite your equation and replace b with negative 3 and keep your minus 5. That's the equation. Good luck on your test tomorrow.